Hello? You guys hear me? Perfect. Awesome. Well, welcome. Let's just jump into it. So this is building high-performance React applications. Oh, there it goes. My name's Joe. I'm technical lead at Best Buy. So we just survived Black Friday. And I know you guys don't celebrate the same Thanksgiving as we do, but I'm so glad you guys still participate in our Black Friday sales in the States. I've been teaching and speaking about JavaScript and React for a long time, and that's me. That's my socials or socials on there. Yeah. Okay. Cool. So great. Is this gonna work? Nope. All right. Do it the old-fashioned way. So how's this going to work? Let's see here. I like these to be a little bit more conversational. So if you guys have questions during this, just feel free to ask it. I feel like it makes sense just like in it. Just raise your hand up, and I can try to get to it. I'll repeat the question too. Yeah, and then I just want to get a vibe in the room too of experience levels with React. So who's been using React professionally for more than, let's say, 2 years? Got a couple. Well, that's pretty good. Wow. How about more than 1 year? How about more than 6 months? How about I've never used React, but I'm interested in learning more about it? Okay, cool. Awesome. So we have a good mix in the room. With this talk, I'm hoping that if you've been using React for a long time, you still learn some new stuff. And I'm hoping that if you've never learned or never used it before, you still learn some new stuff too. I think kind of digging into the nuts of it kind of helps you understand how to use it and use it better. Plus, right now in the front end, there's all these different frameworks and languages, and there tends to be a lot of carryover between them. So if you use Vue or Angular, you may still learn something new too. Okay, cool. And so I do want to talk about fast. So we're talking about high performance, right? We're talking about speed and performance on the front end. And that can mean a lot of different things. Specifically with this talk, speed is going to refer to initial load up times and then also performance after load. So like asynchronous events after the DOM's been fully loaded. Okay, so first of all, why? I think it's important for us to talk about why speed is important, because a lot of times I find I need to justify to the business why they need to give me money to spend on making things go fast. I feel like a lot of time I get pressure to develop features and sexy new things for the users, right, of our site, but performance isn't always the thing that's first considered by the business, so I need to sell that. Who's ever heard anyone say my site is fast enough? Yeah, someone. Okay, that surprised me. I've never gone to a site and said, "Wow, this site is way too fast." Right? Usually, I'm asking, "Why can't the site be faster?" Right? So there's actually some numbers behind that, right? Google's found that 40% of users actually abandon articles if it doesn't load within 6 seconds, and that's on desktop. On mobile, it's even faster. I think it's around 2 seconds. Users start abandoning sites, and I know personally for me that's very true. I got places to go, people see, and I'm not going to sit around waiting on my phone. And Amazon's actually done A/B testing on this exact subject. So they deliberately slowed down their homepage by 100 milliseconds, and they saw that resulted in a 1% decrease in annual sales. And in 2015, does anyone have any idea how much that is? It's a lot. It was over $1 billion in lost revenue they found. That's a lot of money, right? So you can actually find that out for yourself. Google's actually made a little tool, and I suggest you take it out. It's really helpful. I find that specific numbers actually really help selling that stuff to businesses. You can actually estimate how much revenue your company is losing with their whatever loading speeds they currently have, and then whatever you want, your goal speeds, right? You can actually start quantifying that and start selling that. Okay, cool. So speed's important, right? Speed's important. We all know it's important. It's something we should be worrying about. So let's get into it. So the first thing I want to kind of talk about is just the basics of React. I think all of us have probably heard React is fast, but not all of us might know why it's so fast. Does anyone know? Yeah, the virtual DOM. So the virtual DOM, it's not something React invented. It took it from other ideas that came before it, but React is a thing that made it popular. So what is the virtual DOM and how does it work? Basically, the virtual DOM is an in-memory representation of the DOM. So you might know that making DOM calls and working with the DOM directly is really expensive for JavaScript, right? Browsers are really slow at it. It's slow to access it. It's slow to make changes to it. It's slow to query it. And we want to minimize the amount of times that we're actually querying to the physical DOM. And it's much, much faster for us to make queries to a virtual DOM. So in the DOM, right, we all know it's parent and child, which is all just a tree structure. So all it is the virtual DOM is just a tree structure in memory of what's happening in the actual DOM. And we can make changes to that in-memory representation much faster than count the DOM, which is why React is so fast. So what happens with React and how does it actually make updates to the actual DOM? So let's say hypothetically there is some sort of DOM update. Perhaps you're clicking on a button to open a modal or switching a tab or going to a window or something like that. That DOM update will trigger React. And what it'll do is go to the virtual DOM and makes a clone of that virtual DOM with that change in it. And then it does a diffing on the two. React 16, they call it like the fiber engine, and it kind of reconciles them to see what the differences are. Then it will identify what that difference is, and then it does what it calls a patch update to the real DOM. So it'll take that minor difference it finds in the virtual DOMs, which is really fast, and then make a tiny change, only the tiny change it needs on the physical DOM. So the whole idea is that we're trying to reduce the number of times that we actually make changes to DOM. We want to make them as small and often as possible. React does a bunch of other stuff behind the scenes too, like it'll do batch updates to the DOM, so it'll wait till a bunch of them are together, then make an update. All of it's about reducing the number of times you have to go and make updates to the DOM. Okay, cool. So React fast, virtual DOM, great. Let's try to make it go faster. So the short answer for how to make your React application go faster is to only render when you really need to. Only render when you really need to, right? React tries to help you as much as possible to make this happen, but there are lots of things that we need to do in order to help React make those decisions better. Okay, which leads us to the long answer. That's what this whole talk is about here. How do we help React render when it really needs to? How do we help that? Okay. So first of all, we need some sort of benchmark to start measuring performance. So we need to start measuring it. Chrome has a bunch of performance tools in it. But you might have known this, but React in dev mode actually has built-in performance tools integrate directly with the Chrome browser. So if you append $React_perf to any of your React applications in dev mode, it'll unlock a user timing feature in the performance tab in Chrome. And we're going to be using this built-in React performance tool for measuring performance from here on out. And this is what it looks like. So you'll see here I have React perf at the end here, and I have a little sample application you can find on my GitHub. And we're in the performance tab on Chrome, and you'll see here we now have a new user timing block here that actually shows you what's happening under the hood with React. So we can see the entire process of what's happening in there. I'm going to let this run out. It's a GIF, so you can't really control it. So here we go. We're running it through it again. We're running a profile on it. And it'll do the whole thing with, you'll see like the frames interactions, which is default with Chrome. But the user timing thing is the interesting part. So the reconciliation, that's the entire process it takes for making that patch. But under it, you'll see here, we have all of the other things happening on here. So this is an app. We have a list of items on here. And then on the bottom there is a bunch of, each of the individual items in this application. We'll let it go one more time here. So see here, it takes about 34 milliseconds every single time we update that. And then you'll see here on the bottom, it's also updating every single item on the page. I should note, this is the worst possible React application I could write. And through the course of this application, we're going to be fixing it up and seeing how these steps actually improve performance one piece at a time, one step at a time. So 34 milliseconds, and it's updating every single item every single time I update or submit a new item to this list. I mentioned earlier the patching process only updates what it really should. So one of the first things I see here is that we shouldn't be updating every single time. We should only be updating only the items to the list that we need them to update. So let's try to figure out how to do that. Okay, so performance, great. 34 milliseconds, keep that in mind, this can be our benchmark number here. And that's pretty fast, it's really not that bad. But I have run into situations doing this where it gets much worse and there's noticeable lag. 34 milliseconds isn't that bad. But again, we're just using it as a benchmark to see performance gains. Okay, so first tip. I should say too, these tips are intended to be very practical and very simple things you can start taking home and start making your applications fast today. I know a lot of these perf talks can get kind of abstract. I'm hoping this will be a little more concrete. Yeah. So first thing, using key correctly. So let's see here. Keys. I didn't really know what a key was. I've been actually using React incorrectly or keys incorrectly for years. Before I learned how to use them correctly. But keys, let's see here. They're used to uniquely identify elements in React. So we'll get into that. But first of all, who's ever seen this error pop up when they're making a React application? Right, you see, this is usually when you're iterating over a list of items on there. I still do today. I always forget to put key in there until React reminds me. But something I did for a long time, it says just it needs a unique key for each prop. So when I was creating these new items, something I would just do was math.random or add the index of the array into that key, and the warning went away. But you should never use math.random or the index of an array for this unique key. And that's because this should be used as a unique identifier for React for that key. So what that means is React, as it's doing the diff between the virtual DOMs. So it's seeing, let's say for this example, you're adding a new array to that list, right? And you're using the index in that array. If you add a new item to the top of the list, each item on the array is going to have a new index, which means that React no longer can keep track of where things are. So between the diffs, right, in the virtual DOM, it needs to know that this item here matches to this item here in the new virtual DOM. And if you've scrambled those unique keys, React is no longer able to tell which of those is different, and it's going to re-render that whole item every single time. So what I do for these is, and I would recommend for you guys, is typically what I'm doing on the front end is I'm digesting an API from some backend endpoint, and 99% of the time I have a unique ID that comes with those API items. I would highly recommend using those instead. But there are those unique situations where you do not have a unique key coming from the backend. Maybe you've asked and it's going to be 6 months before you get one. So what do you do? What do you do? I don't have a unique key. What do I do? What I would recommend doing is hashing. So what we do if we don't have that, which does happen, we'll typically hash that object or some unique part of that object. So we have a unique key that remain unique between diffs, right? Won't change. If you don't know hashing, don't worry about it. Just Google good hashing algorithm JavaScript. You'll be fine. I have one. I don't know really how it works, but it works great. It keeps a consistent thing. So don't worry about it too much, but they can be really helpful in this situation. Okay. Don't ever use this again. I use this for years, for real. It's if you use it, hey, no worries. No worries. Okay, so let's see how that actually improves performance. So we have the same app, same thing. The only thing we've used now is we're using keys correctly. So let's actually see how that improves performance. Remember before we had our 34 millisecond benchmark. And now you'll see that we're down to about 17 milliseconds. And it's still updating each item on there, but we've halved the amount of time it takes to re-render now. Because React is able to make that reconciliation much faster, keeping track of items across the virtual DOM diffs. So we're able to double double our performance just by using keys correctly. One, super simple. Let's see that one more time. Yep, 17 milliseconds. Still updating every single item, but it's much, much faster. Okay. So, next tip. So there are situations too where you want to be able to get in there and actually tell React explicitly when it should render. Enter should component update. So should component update is a lifecycle method built into React, kind of like component did mount, component will mount. Excuse me. That allows you to explicitly tell your React application when it should render. So by default, React will re-render your component if the props have changed or if the state has changed. It does a look and see, are these different? If they are, great, then I re-render. But there are instances where maybe you are passing props down that specific component doesn't care about, and you don't actually want to re-render. A lot of times what we do too is we get a whole chunk of data from our backend APIs, and we just pass that down through our children components. But we only actually care about a couple of those props. That's when this one becomes really handy. So this is the component we're actually using in this example. So it's just an item component, and all it's doing is displaying title coming through from our data. But if we refactor this, we can tell explicitly when to state. So maybe we're passing through like the timestamp and some other stuff, but we only want it to re-render if the title changes. So that's where should component update comes in. So you're given two arguments, the next state and the next props. And you can compare that to the current props and current state and return a Boolean of whether you want it to re-render or not. So obviously true if you want it to re-render, or false if you do not want it to re-render. And all I'm saying is, if anything else changes, I only care if the title changes. Okay, let's see how this impacts performance. So right now we have our keys set correctly, and now we've updated should component update on each individual item on here. And we're down to about 9 milliseconds, so a little less than half. Decrease the time again. And you'll see here it's checking should component update now and not checking the entire item, right? Which is much, much faster for it to check that Boolean status. And I think there should be only one on there that's actually re-rendering the item. Let's double check, I can't remember. Probably one of the big ones on there. You see some of the items are a little bit wider. Yeah, okay. Cool. So we're down to about 9 milliseconds. So much fast. Turns out, while doing research for this slide deck, there's a lot of Sonic memes out there. I had no idea. Pretty popular in the meme world. Okay, great. So should component update, great, cool. But in my humble opinion, it's a little verbose and it's gonna be a little overkill sometimes. Which leads us to our next clip, our next little tip here, which might make that last one less useful. But pure components. Pure components is actually something I learned about recently too. Most of the time I end up using just regular vanilla React components, but pure components is another built-in React component state that you can actually make use of. And we actually use these pretty widely in our React applications today. So what is a pure component and how is it different than a regular React component? So shallow components, or pure components, what they do is a shallow comparison of all props and state, and it does this in a really efficient way. So basically what it does is exactly what should component update does, but for you automatically. So, but let's dig into that shallow thing a little bit too. So you may have heard of like shallow and deeply nested changes or objects. And by shallow comparison, what that means is if you're given props, it'll only check the top level keys and values, not any of the deeply, like if you have an object within an object, it won't check those. Anything deeper than one level, it will not check. So for this example, right, it'll check all of the top level things, but none of the deeply nested changes. So pure components, they're really useful if you have a very horizontal or flat data structure, which I recommend. Keep it very simple, only pass the props you need in as shallow as possible order to your children components. And typically, I use pure components if the data structure is really simple. If we have really complicated data structures, then I'll use a regular React component with should component update. So let's take a look at what this actually looks like. We have our should component update, right, on our item component. And let's refactor that to use our pure components, right? Much cleaner, much cleaner. And it does exactly the same thing. See, this next slide is the only non-Sonic slide in here, but I just couldn't resist it. It's too good. This is how this makes me feel. Woo! Feels good. Right, getting rid of that code, it looks much cleaner. It's more performant, right? Pure components, they're awesome, right? Woo! Feels good. I love deleting code. No, that's great. Stuck, yeah. A good slide to get stuck on, though. Yeah, pure components, easy, right? You're just changing the pure component name, right? Instead of sending component instead of pure component, or pure component instead of component. And we get some perf changes. So let's take a look at what this actually does. We should expect, yeah, we have a question.
Yeah, why wouldn't you just like make that a function that just returns like an H3 with the title instead of like
Oh, yes, we will get to that too, yes. So the question is, why didn't we just make that a stateless or pure component? Yes, we will totally get to that. That's a great question, because this says no state in it, so what's the point? Yes, no question? It's, could you say that the question one more time?
For the pure component example, you had the X over the key that pointed to the array.
Oh, yes.
Or anything that points to the reference type, or does it just check for type default? Like if the array reference in it, it's effectively the same, or does it just ignore it entirely?
It will check pointer references, so if it's the same, like, it won't check the contents of it, but it'll check to see if it's the same pointer reference in memory. So if you're doing two diff checks against like post and new, it'll check to see if it's the same object or not. But if you're making changes to it, it won't. It's dangerous. It's still dangerous. JavaScript gets weird about those pointer references and objects. But yeah, yes, it will. Good question. Oh yeah, animations you can't skip through. I love that animation too. I refactored this entire slide deck just to use that magic code sliding. Okay, so let's take a look at actually how this works. We want to compare pure components to should component update. And if it is in fact kind of a replacement for it, or it does the same thing, then we should see about the same speed of boost that we saw before. And I think we're at 10 milliseconds. We were at 9 milliseconds before with should component update. And you'll see here now it's only updating the single item to the DOM when we're making the update. So 10 milliseconds, whatever, 1 millisecond difference. It's about the same, right? Awesome. Great, right? It's clean, pretty easy to do. So now we have two pretty easy tips, right? Just make sure you're using keys correctly. Using should component update if you have a really complex proper state structure, and then use pure components if you have a really simple one. Okay, next tip. Using immutable data. So this kind of ties into that pointer question too. We'll get explicitly too into the stateless components. But immutable data and functional programming are like some of those fancy terms you've probably been hearing a lot about. And they're becoming increasingly popular on the front end for a lot of reasons. But you may not know why. Why are they actually helpful, and why do they help JavaScript actually perform faster? So immutable data, it's basically a fancy word for making a new copy of an object. I just thought that was just a fancy looking, he's not a well-drawn Sonic, but he's fancy. So it's a fancy word for making a new copy of an object. And if you're new to JavaScript, making copies of arrays and objects is pretty complicated in JavaScript. But making copies of objects and arrays actually allows you to makes tracking changes much faster for JavaScript and for React. So why? This is getting into like pointer references in JavaScript. So when you're making a brand new object in memory, it basically saves a pointer reference to that object, and then it shows you or points to where the data is actually stored in. for JavaScript. So you'll see here this object has a bunch of keys in it. And when we do a deeply nested search of those keys, we actually have to traverse through each of those keys in there to check to see what the values are, to see if it's what we're looking for. This is really expensive. And if we are mutating an object without making a copy of it, JavaScript has to do that. It has to go through and actually check to see if all the keys are the same or if there's any differences, which that takes n time. If you're into like big O, that's really expensive. If you make brand new copies of objects, JavaScript does something a little bit different. It doesn't actually care what the contents are, but if you're making a brand new copy, it actually occupies a brand new memory register, right? So we have a brand new object, and JavaScript doesn't have to check the contents of those keys to see if they're different. It just assumes that if it is in a different memory location, it's a brand new object and it'll do a re-render. So all it has to do is check, is this different than this spot? If it is, great, re-render. I don't care. I mean, it doesn't have to check the contents of it. Much, much faster for JavaScript to compute that. So that's why immutable data is so much faster. And even if you're not using React, it helps in any programming language you use, or like any front-end framework you use, excuse me, with JavaScript, much faster. I think one of the big rises of functional programming today is due to the fact that our devices have so much more memory in them, right? Before, memory was a huge constraint, and making copies of stuff could be faster, but we had this big space constraint. Now it's not really a big a constraint for us anymore, so we're willing to sacrifice space for performance. And it turns out actually the JavaScript garbage collector is really good at handling these things and can get rid of them really quickly, so it isn't that big of a deal. Okay, cool. So immutable data, it's fast wherever you are. Let's see here. I'm going to skip this actually. Yeah, that's just like confusing. Immutable data too. I don't use this all the time, but some of our projects we do use immutable.js. It's another JavaScript library developed by Facebook, who also develop React. So they play really nice together. Typically, I use immutable.js for my React Redux projects. Just keeping my Redux store immutable, because like I said earlier, doing immutable stuff in JavaScript can be kind of confusing and hard. But it enforces immutability, which is awesome, and it actually turns out that it makes it perform faster too, for the very reasons we just discussed. Right, and it behaves exactly as we expected. Okay, cool. So immutable data, super useful. Try to use it more. If you're not thinking like immutable data, that's fine. Don't worry about it. I think it's great about it too is it's completely opt-in. So you could just one day you could choose to go tomorrow and start trying to just build new stuff using immutable data, or refactor a little something you did yesterday and just start using it. Just push yourself a little bit further and try to like use that stuff. Opt-in. Okay, using immutable data. All right, next tip. Using universal or using universal React. So this one is a little. It doesn't actually make it. The only difference with what universal React does is it server renders your React application. And it won't speed up your application once it's loaded into the user's into the DOM. But what it will do is make it the time to first paint of your React application go so much faster, which can mean a lot. A lot of trouble with single-page applications these days is that there's a lot of JavaScript coming in, and there's a really long load time, right? We've all seen like Gmail, right? Has that loading screen at the beginning now. It's a spa. A lot of applications, I think, are really slowing down that initial load-up time. They're really, really fast once that initial load-up times come, but to start out with, it really drags. Universal or server rendering your components actually can help speed up that initial load time. So how does that work? We refactored this recently at Best Buy too. So all of our front-end components are now being server rendered. So what that means is that we have node-based React microservices that render all of our React components and serve those before they get served up to the client. We do both. It does both. It's kind of weird, and we'll talk about some of the cons of it too. You do this initial component did mount. The initial state of the application gets managed by the server, and you send off just an HTML initial rendering of that component to the client. So that first paint is super fast, right? We've already done it for you, just like in the good old days, right? And we've, here's the initial paint, and then we send over the React on the back end, and then the React code on the, gets served up and kind of compiled by the browser in the back end, and then that replaces the initial render. So from a user's perspective, it's there, it's fast, it's usable, and then we come with React, replace it, and then you get that super speedy React experience afterward too. So it's the best of both worlds, right? You get some of the old school initial speed, and we can cache that stuff. We can do a lot of crazy stuff on the back end to really make that initial experience go a lot faster. So how does it work? Yeah, our React component sends off a static HTML string, and then it'll also send off the React code and CSS for that component on the back end. But it'll initial that initial string super fast, and then we send off that React code, and that replaces the initial static rendering. So from a speed perspective, it's not a speed afterload. It's an initial perception. And a lot of times with performance, you don't actually have to go faster. You just have to make your users think your application's going faster. Because if you just see it there, it looks better, right? They don't have to sit and wait and look at a loading screen or white space or whatever. It's there and it looks like it's usable, and they can start figuring out what they're going to do next on your page. So some pros of that, right? First page request is super fast. And with server-rendered React, we still have one code base for both our server and our client. So our engineers are still working with one single code base. But I will say some of the cons of that we've seen is that debugging can be a little bit trickier. So something we've seen a lot, we've been retraining all of our front-end engineers to be full-stack engineers and managing these node-based microservices. And we've seen a lot of our front engineers are really used to debugging in Chrome. But now with the server rendered, we have to both debug in Chrome and on our server. So that's been a big change for a lot of our teams. And kind of figuring out where the error is. It's hard to tell. It's been hard to tell for some of the people just starting to transition to it. Managing configs has also been challenging too. Now we need both. We used to just have client-side configs, but now we need server and client-side configs to make sure that we're managing the initial state correctly on both sides. And the last thing too is obviously there's no DOM on a server. So doing that initial render happening on the DOM is a little bit trickier to troubleshoot as well. Again, it's just been kind of a learning curve for all of our teams. Yeah, we have about half our site refactored into serverless or to server rendered or universal React. So yeah, we're pretty productive at this point, but it definitely took a while. Okay, server rendered. Next tip, building for production. This one I think is another pretty simple tip that I just want you to go back and check on this. But when you're doing the build step, make sure you have npm environment equals production in your npm script for building, or in your Webpack file, however you set the node environment. Basically what happens is this environment variable allows React to know how it should build itself. So by default, if you don't set it, it builds into develop mode. And it has a bunch of really great, integrates with Chrome dev tools. It has that built-in React dev environment, or that performance tab that we saw before, right? There's all this cool stuff for us to make debugging and developing our React applications a lot faster. But if you set it to production, what it does is it minifies and it strips out all of the dev tools that we use. So it makes a much, much faster build of React. And actually, we see builds that go 2 to 8 times faster than your development build when you set this one. Just one little tag. Just make sure you have it. Just make sure. Your console will still warn you too if you don't have it set in this environment, but it's always good to check. Let's see how this actually performs. So again, we don't have the performance tools or the dev tools built in with React anymore, so we're just going to use the vanilla time to paint as our performance indicator here. You'll see here we're down about 6 seconds here to repaint the 6 milliseconds to repaint per event. So we're able to get that even, make it go even faster. Okay, a couple more tips. So stateless components, this is to your question too, why don't we just refactor those stateless components? For sure do them. So stateless components, you may hear them called functional components, stateless components. I prefer stateless because functional is kind of a loaded term with functional programming. Stateless, I think, is a little more descriptive because that component has 0 state, which is why I prefer that term. Yeah, let's take a look at what that actually means, and then we can talk about why that helps. So again, here's our React component. Whoops. And oh yeah, so we've refactored it to use, it's just returning a, instead of extending React component, all it is returning a JSX string. So in React 14 and below, what React actually did with these was it just wrapped it with a regular React component behind the scenes, and you actually got 0 performance gains from actually doing this. Newer versions of React, there are some optimizations to them, but I've seen 0 documentation about why. The only thing I've seen is Dan Abramov tweeted at me and said that React 16 has made him a little bit faster. That's all I really know. There's been 0 things in the documentation about why they're actually faster, but I'm just taking Dan Abramov's word for it that it is going faster. So even if you do not, so you get slight performance gains on them. I don't know what they are, but I still, even when I was making recommendations to the team on React 14 below, I still recommended using functional or stateless components because they're way easier to test, way easier to reason, less code to maintain. Like it's just, there's so many more reasons for you to like use them. They're great either way, but now you even get performance gains on them as well. Okay, a couple quick tips here. Analyze your Webpack bundle. So a lot of this stuff are like micro optimizations, which I have really mixed feelings about, which I'll get to in a little bit. Out of all these tips, I'd say that this has been one of the biggest ones that we've done to improve performance at Best Buy. This one has had the largest impact out of any of these tips. So analyzing your Webpack bundle. We use a tool called WEBPACK Bundle Analyzer, and it gives you a actual like interactive model of what's happening in your Webpack bundle. I think Webpack's great. However, I think there's a lot of black magic in it, and people use it and don't really understand actually what's happening in the bundle or what's going up to their clients. I think that separation from of actually seeing what's going on allows a lot of sloppiness to happen. And something I see a lot in our teams is that gigantic packages that we do not need end up in our bundles without us knowing it. So things like images, humongous images that should be offloaded to our CDNs, those should be offloaded, or gigantic packages. Most recently, someone tried to bundle in Lodash for, or no, it was Moment.js for one single method on there, and it was like 2 megabytes. It's huge. I don't know if you've ever seen Moment. It's massive. So basically, I had to go back to our engineers and say, like, do we really need this giant package, right? It's allowed us to kind of push back on our engineers and say, like, do we need this? Is the cost of this worth what we get out of it? We ended up pulling it and just building the method ourselves, and it saved us a massive amount of space in our bundles. But these add up, right? Each of these packages add up little by little, and at the end of the day, we end up, and NPM's great, but I think NPM allows us to like not think about what's going into our applications, right? I find my job a lot of time as tech lead is to kind of push back and ask, do we really need this? Because reducing the size of your bundle allows it to travel through the internet tubes faster and allows browsers to read your code much faster because there's less JavaScript for the browser to parse. The less you have in there, the faster it's going to go, and this has been the biggest impact. It's helping us get in there. It also allowed us to, because you can see your node modules over here, it allows us to see packages we import from other teams and refactor their code as well. Like, hey, this package is using this package, it's using this package. Then we can let that team know, like, hey, you have just like this gross image or huge bundle size in here, like, and we can make pull requests to other teams too. It's allowed us to see everything in our code. Let's see here. I only got 5 minutes left, but this is an example of Webpack bundle, how we do it. But this, well, if you want, the slides are online, so you can look at it too. Okay, a couple minutes left. I'm just going to do some quick thoughts, and then I'm going to get out of here. But things to think in mind when you're thinking about front-end performance. These are not React related. These are just general performance tips I'd recommend too. But think about what you're sending, think about how you're sending it, and think about how much of it you're sending to the client. So when you're thinking about what, ask yourself, do we really need this package? Do we really need a CSS framework? Do we really need that JavaScript framework? And do we even need React? Do you need Angular, do you really need it? You should be asking yourself these things too, constantly trying to edit yourselves down to the smallest possible thing. Think about how you're sending it. So if you're using HTTP 1.1, you're capped at 6 concurrent requests to a browser. And typically applications are sending hundreds of images and JavaScript and CSS files down to the client. HTTP 2 allows you to send that much faster, a multiplex that, and it obliterates that 6 connection cap. Making sure you're preloading your assets, specifically images and CSS files. So making sure you're fetching that before you need it. And then if you are using HTTP 1.1, asking yourself, are you bundling your packages? HTTP 2, that's less of a concern. But HTTP 1.1, definitely you want to be thinking about bundling. And how much? Making sure you're minifying all your text files. That means your CSS and your JavaScript. Compressing those images down. I'd recommend using SVGs. Those are great too for the browser. And then client hints, which is brand new. This proposal just came out. We're looking at how to utilize this right now. Basically, though, what we're looking at is for a client hint comes from the browser and tells you what the browser is, so you can send exactly the type of assets you need to that browser. So for example, we now are able to split out our code so that older versions of IE received a larger polyfilled version that will work in their browsers, and more up-to-date browsers receive a smaller non-polyfilled version. So we're able to explicitly define what bundles and what packages each different clients need to serve them up faster. Okay, so the most important slide of all, I think as engineers, we get really excited and nerd out about some of the performance stuff, and it's really exciting, and it can really take a long time, right? And I think it's really a balance between delivering product stuff and then kind of itching our performance nerdy engineer, you know, that bug. But I still think the most important thing you can do is make it work, then make it fast. It isn't the cutest Sonic. So make it work, then make it fast. I strive this with all engineers on my team. Like, the product doesn't care if you have the fanciest, coolest, fastest code in the world that doesn't work. They do not care. They care if it works. And if you're building an application, I highly recommend get it out the door, start using it, and if you start seeing it slow down or customers are complaining, that's when you're going to want to start doing this stuff. But don't pre-optimization is the root of all evil. It's a very common term you've heard in engineering. Just get it out the door, make it fast. I think being aware of this stuff up front allows you to make some smart decisions when you're building it, but don't let it consume your world while you're building it. I would maybe audit every once in a while performance and maybe keep track of it, but again, just deliver and then make it fast. Okay, cool. So let's see here. Recap. I love this one too. I feel like the recap button wakes people up for some reason. So it's like this one, okay, great. These are good ones to take pictures of too, or whatever, if you want to. So all the tips we've learned about today. First of all, using keys correctly. Do not use math.random. Do not use index and array. Use either unique keys delivered with those data or hashes of that data. Manages should component update. So use should component update if you have really complex state or prop structure. Otherwise, use extend pure component. That allows you to do a shallow comparison really quickly. Note, though, too, I would say a lot of new engineers to JavaScript won't know what pure components are. And I've seen junior engineers who don't really understand React make changes to props or change the state structure to more deeply nested using a pure component, and it doesn't update, and they spend hours trying to figure out why. Just make sure everyone knows what it is. Using immutable data, JavaScript compiler is able to make differences much faster. Right? You can check just pointer references as opposed to deeply nested data changes if you're using immutable data structures. Use stateless components. I don't know why, but Dan and Imrov said, great, use them, so I would recommend using them. And build for production. So you see 2 to 8 times the speed improvements if you set the node environment to production. Strips everything out, minifies it, makes it faster. The biggest one we've seen work for us at Best Buy is analyzing our Webpack bundles. So you want to make those Webpack bundles as small as humanly possible. And we do that by asking ourselves what's in there and pulling everything out that we do not need. Render when you only when you need to. And then most importantly, make it work, then make it fast. I want to make the runner look like he was moving, but he just looks like he's farting. I don't know if there's speed line emojis, but whatever. We're going to use the farting runner for now. Okay, great. Let's see here. I don't think we have time for questions, but I will be mingling around with this talk if you want to talk about specific case of your company or project you're working on. Otherwise, thank you so much.